Hello and welcome to my lecture for Philosophy 4400 on the fine-tuning argument and the multiverse hypothesis. This is the fine-tuning argument. So it's been noticed that there are certain physical parameters of our universe which are adjusted in such a way that makes it possible for life to exist. And it's said that this is extremely improbable in the absence of some sort of explanation. And that's because the parameters have to be adjusted to extremely specific values in order for life to be possible. Now, these are some examples. So first, it's been calculated that if the gravitational constant were slightly larger than it actually is, the universe would have recollapsed long before life evolved. Or if the gravitational constant were slightly smaller than it is, then the universe would have expanded too fast for stars to form, and so again there would be no life. Or for another example, it's been calculated that if protons were 0.2% heavier than they are, they would decay into neutrons, which would destabilize atoms. And again, then there would be no living things. Perhaps the biggest example of the fine-tuning is the incredibly low entropy initial state that the universe is believed to have been in at the time of the Big Bang, 14.5 billion years ago. As mentioned in a previous lecture, Roger Penrose has calculated that the probability of this initial state occurring simply by chance, or in other words, if you just pick a random possible state of the universe, the probability of getting the actual initial state of our universe is something like 1 in 10 to the 10 to the 124 power. And I note that this extremely low initial state, extremely low entropy initial state, is the reason for all of the interesting processes, all of the order that we see in our world today. It's been moving towards higher entropy over time, and it had to have started in this incredibly low entropy state in order for the amount of order that we see today to exist, and therefore for life to exist. So, we conclude from this, perhaps, that some explanation for this phenomenon must be correct, and there are two main explanations that people offer. So some people think the explanation is intelligent design, sometimes known as God. That is, some people think maybe there was an intelligent being who was extremely powerful, who intentionally set the parameters of the universe in order to make life possible. Now, this would presumably have to be some kind of almost supernatural being because it has the ability to modify constants in the laws of nature. The other hypothesis that people offer is the multiverse hypothesis. It's the theory that there are a very large number of different universes, and they just vary in the values of their physical parameters. So, for example, maybe the gravitational constant differs from one universe to the other. And it just happens that there are only observers in the universes where the parameters are within the range that allow for life to exist. And so every time an observer looks, they find the parameters to be within that range. Now, this intelligent design theory and the multiverse theory, these are the two leading explanations that people have proposed. It's very difficult to think of other explanations. Perhaps there's one that we haven't thought of. But the main way that people argue for one of these theories is essentially by criticizing the other theory. The multiverse explanation is sometimes said to be an example of anthropic reasoning and to be making use of the anthropic principle. When you read the literature on this, it's kind of hard to figure out exactly what the anthropic principle is because people say different things, and sometimes they say things that are really quite different. So sometimes the anthropic principle is basically given as a tautology that, if you're an observer, then you should expect to find yourself in the sort of universe that allows for observers to exist. And so, it's tautological that observations will only occur in conditions in which observations can occur. But sometimes it seems like the so-called anthropic principle is a stronger and apparently false idea that, for example, you don't need any further explanation for the universe being this way. I.e., if you find that the universe is the way that allows for observers to exist, you don't need any further explanation besides the fact that you wouldn't be here if it didn't have those characteristics. Okay, note that some advocates of the multiverse theory claim that the existence of a fine-tuned universe is evidence for the existence of the multiverse. So recall the article from Max Tegmark that we discussed last time. This is a quotation from Tegmark. He says, "Most, if not all, of the attributes set by symmetry breaking appear to be fine-tuned. Changing their values by modest amounts would have resulted in a qualitatively different universe, one in which we probably would not exist." Right, and then a little later he says, "These examples suggest the existence of parallel universes with other values of the physical constants." So I want to focus on that question. Is this true? Is the fine-tuning actually evidence for the existence of other universes? There's an important objection to this argument for the multiverse. It's sometimes called the "this universe" objection. So to explain this objection, I start with an analogy. Imagine that you're flipping a coin. Let's say you flip the coin 10 times and you get 10 heads in a row. Question: is this evidence that there are many other coins being flipped somewhere? Now, I hope you can see just intuitively that the answer to that is no. Note, by the way, that if you think that the 10 heads in a row is evidence for there being many other coins that are flipped at least 10 times, any outcome that you got could be argued to be evidence for there being many other coins, because any result that you get of the 10 coin flips has the same probability, namely 1 in 1024, because that's the number of possible outcomes. So if you think that this one gives you evidence for there being other coins, everything that happens gives you, any result gives you evidence for there being other coins. Okay, now let me explain why this isn't evidence for there being other coins that are being flipped. So it's true that the existence of many other coins that are flipped increases the probability that some coin comes up heads 10 times in a row. That is, at least one does that somewhere. But it has no effect on the probability that this coin would come up heads 10 times in a row. And your evidence is the latter. Your evidence is that this coin came up heads, not merely that at least one coin somewhere came up heads. And the reason that's the correct description of your evidence is, in general, the correct description of your evidence is the logically strongest relevant thing that you know. If you have two different ways of describing the evidence, you have to take the one that's more informative or more specific. That's a thing that you actually know. And so the coin flip result is completely irrelevant probabilistically to the multiple coins hypothesis. The multiple coins doesn't explain the evidence because it doesn't make it more likely that this coin would come up heads 10 times if there are a bunch of other coins being flipped. Okay, now if you accept that, then apply this to the case of the multiverse hypothesis. The existence of other universes increases the probability that there would be at least one universe that allows for life, but it doesn't increase the probability that this universe allows for life. Right? And so therefore, just as in the coin flipping case, our evidence is completely irrelevant to the multiverse theory. The existence of these other universes has no effect at all on the probability of our evidence, and therefore our evidence does not support that hypothesis at all. Here's another analogy, the firing squad analogy. So imagine that you're up for execution by a firing squad. There are 50 sharpshooters, and as they get ready and aim, you're preparing to be killed, and then somehow miraculously all of them miss. And so after this happens, and you open your eyes and notice that everybody has missed, you would start thinking about how this was possible. You might wonder, was there some kind of collusion? Maybe somebody got into the armory and replaced all of the bullets with blanks, or maybe somebody has paid off all of the firing squad members to let you live. But here's one thing that you probably wouldn't think to yourself. Oh, maybe there's just an enormous number of firing squads somewhere in the universe, so it was likely that at least in one of them they would all miss. You probably wouldn't think that. Now, hopefully you can see intuitively that that hypothesis would not explain your evidence and would not be supported by the evidence. And I give this example. This is analogous to the coin flipping example, but I give this example also because it shows that this idea of anthropic reasoning, whatever exactly that means, is not relevant. That is, the fact that you wouldn't exist if this hadn't happened is irrelevant. That doesn't help the inference that, you can infer that there are other firing squads or whatever. It's true that you wouldn't be here if they hadn't all missed, right? Which is just like the fact that we wouldn't be here if the parameters of the universe were not adjusted in such a way as to make life possible. But it's false that you shouldn't infer anything from that, or that you don't need a further explanation for why all of these shooters missed. You do need an explanation for that. It is not a sufficient explanation to say that you wouldn't be here if they hadn't missed. So similarly, you still need an explanation for why our universe is fine-tuned in such a way that allows life to exist, and it's not a sufficient explanation to just say that we wouldn't be here if it wasn't. Okay, now these are some things that you could say in defense of the multiverse argument, and so this will make things a little bit more puzzling. So here's another analogy. I call it uranium atom bob. Imagine that you have a sample of radioactive uranium in a box, and you're reliably informed that it contains either a single atom of uranium or a large number, like a macroscopic sample of uranium. You have a detector that detects radioactive decay, and the way the detector works is the first time an atom decays, it detects that, and then it records that an atom decayed, and after that, the device no longer does anything. So all you can tell by looking at the device is if at least one atom decayed. Okay, so you have the box, you leave it alone for an hour, you come back and you see that the detector records that an atom has decayed. Okay, now I note as an interesting side point that the half-life of uranium-235 is 700 million years, which means that any given atom of uranium has a probability of 50% of decaying within a period of 700 million years. Or in other words, if you go away and leave it, half the uranium, if you come back after 700 million years, half the uranium will be gone because it radioactively decayed. Okay. So at this point, it seems like you could reasonably infer that the box probably contains many atoms and not just a single atom of uranium. That's obviously a good inference. Okay, but now suppose we add that all of the uranium atoms on Earth, oddly enough, have names. They were named sometime back in the 1970s. And the detector, when it detects a radioactive atom decay, actually somehow it knows the name of the atom that decayed. So you look at the detector and you see that it has recorded that an atom named Bob decayed. Okay, so now this is a slight modification to the story, but does this alter the inference that there are probably many atoms in the box? So you might give an argument that's parallel to the this universe objection, right? So you might say, well, our evidence is not merely that some atom decayed. Our evidence is this atom decayed, or Bob decayed. And the probability that Bob decayed is completely unaffected by the presence of other atoms in the box. This is analogous to in the this universe objection, saying that the probability of this universe being fine-tuned is unaffected by the existence of other universes. Okay, so by parallel reasoning, it looks like you could say we can't infer anything about whether there are many other atoms in the box. All we know is at least Bob was in the box and Bob decayed. Okay, now hopefully you can see that that's not correct. So it seems like the reasoning, this universe type reasoning is correct about the coin flipping example and about the firing squad, where you say, the existence of other coins is not relevant to whether this coin comes up heads. But it seems like that similar reasoning is not applicable to the uranium atom Bob example. So now I'm going to try to give the correct theory of evidence that will get these results. right? So here's the theory. Your evidence supports a hypothesis H if and only if H raises the probability compared to the alternative hypotheses that you would have the qualitative evidence that you actually have. Now I note some things about this. Note that the hypothesis in question has to predict your having the evidence that you have, not simply someone's having it. So if the hypothesis makes it more likely that someone somewhere would have evidence like that, but not that you would have evidence like that, that's irrelevant. Also, a point about what I meant by having the qualitative evidence that you have. What I'm trying to emphasize is that if you have two situations that would be indistinguishable by you, those situations should count as you having the same evidence. So when we describe what evidence you have, we should describe it in such a way as to have that result, right? That we won't count indistinguishable situations as being different evidence. For example, if you see a person, you get a certain amount of evidence. If you see a person who looks just like them, like you see their identical twin and you have no way of telling the two apart, we should count that as you having the same evidence. So we shouldn't say that's different evidence because you saw a different person, for example. And the other point I want to make is confirmation is comparative. So a hypothesis, to be well supported, it has to predict the evidence better than the alternative hypotheses. That's the relevant comparison. Note, by the way, that the relevant comparison is not is the probability of the evidence that you actually have greater or less than the probability of some alternative evidence that you could have had. Question also isn't whether the evidence that you have has a absolutely high or low probability. The question is whether the evidence that you actually have has a higher probability given a particular hypothesis than that same evidence has given an alternative hypothesis. So if yes, then the first hypothesis is supported. Okay, so now let's apply this theory to the examples that we previously discussed. So return to the coin flipping example. So the multiple coins theory doesn't affect the probability of your observing 10 heads in a row. So it has no effect on the qualitative evidence that you received. So you don't have any evidence for there being multiple coins. Similarly for the firing squad. The multiple firing squads theory doesn't affect the probability of your having the experience that you had, namely surviving the firing squad. So you don't have any evidence for multiple firing squads. Okay, what about the uranium bob example? So there's a couple of ways that we could analyze this case. So here's the first description. It looks like your evidence in this situation is that, first of all, at least one atom decayed, and secondly, its name was Bob. In fact, that the first atom that decayed, its name was Bob. If there were others, you don't know what their names were. And note that the situation that you have is indistinguishable by you from any other atom decaying and being named Bob. So this is a fair description of what your qualitative evidence is. Okay, but note that the second part of this evidence, the fact that the atom that decayed was named Bob, that's irrelevant. Because different theories about the number of atoms that were in the box don't make different predictions about what the likely name of the first atom to decay would have been if an atom decayed. And so therefore you can ignore point 2, that the atom's name was Bob, and you can just treat the relevant evidence as being that an atom decayed. And since the existence of many atoms in the box makes it more likely that an atom would decay, that is, at least one would decay, that means that you have evidence for there being multiple atoms. Okay, so here's a second possible description of the case, and I think this analysis is also correct. So suppose that uranium atom Bob had somehow been identified independently of the decay event. Maybe there was some reason why you were thinking about this particular atom before. Maybe it's your favorite uranium atom and you were wondering if it would be in the box. And then you get this evidence and you found out that uranium atom Bob was in fact in the box and did decay. Well, Bob would be more likely to have been in the box if there were many atoms in the box than if there was only one. So once again, your evidence strongly supports that there were many atoms in the box. Now, the presence of many atoms in the box doesn't change the probability that Bob would decay if Bob was in the box. That is, the other atoms wouldn't have any effect on Bob's probability of decaying. But the existence of a large sample of uranium just makes it more likely that one of them would be Bob. Okay, so at last, let's apply our account of evidence to the multiverse theory. Is the multiverse theory supported by the fine-tuning evidence? And basically what I want to say is it depends upon your theory of persons and personal identity. There are two views of persons, and on one view, the multiverse theory is supported, and on another view, it isn't. So here's the first view about persons. The first view is that persons could exist, a given person could exist in different universes. So in particular, on this view, you could have existed in another universe. If that's true, then the multiverse theory raises the probability that you would find yourself alive at all. And since you do find yourself being alive now, that would be evidence in favor of the multiverse. Now, why might this be true, that you could exist in different universes? Well, suppose you think there's just some purely qualitative conditions for something to count as you, for a person to count as you. In that case, there could be you in different universes. Or suppose that you have this immaterial soul, and suppose you think that the soul does not actually have a spatial location, but it just gets connected to bodies depending upon certain qualitative conditions that the body satisfies. In that case, maybe your soul could be attached to could have been attached to different bodies in different universes, right? And so the more universes there are, the more chances there are for you to be alive, right? And so then we would have evidence for the multiverse just from the fact that you are alive. The other view about the nature of persons is that a particular person could only exist in the particular universe that they actually exist in. Why might you think this? So one reason is that many philosophers endorse a thesis called the essentiality of origins, which holds that a person had to come about by the particular token causes by which they actually came about. For example, in order for a person to count as you, the person has to have come from the particular sperm cell and egg cell that you actually came from. So if somebody creates another person from another sperm and egg cell, even if it has the same genetic code, it would just be a clone of you or an identical twin. It wouldn't be actually literally you. The other reason you might think this is many philosophers are physicalists, so they think that a particular person is just a particular physical object. And a particular physical object couldn't exist in another universe. In another universe, there could be a physical object that's very similar to one of the objects in our universe, but it couldn't be and could not have been that very object. Okay, now if you hold this view, then the multiverse theory has no effect on the probability of your existing. It doesn't affect the existence of other universes, doesn't affect the probability of your existing in this universe, and you couldn't have existed in any of the other universes. So overall, the multiverse theory is completely irrelevant to the probability of your existing and being alive and conscious and so on. And so therefore, we would not have any evidence for the multiverse theory on this view. Okay, now I'm not going to try to settle which view of persons is correct. So I'm simply going to rest with this conclusion that the fine-tuning evidence supports the multiverse if and only if persons can exist in different universes. Otherwise, if you don't like the multiverse theory, the intelligent design theory is the remaining major alternative.